Okay, so look, if you learn electronic circuits, or teach circuits, or maybe you just like to build them, I just have to show you something cool. It's called EveryCircuit. Let me quickly put together a very simple circuit. It's a voltage source connected across a resistor. Nothing fancy. Looks like a circuit from a textbook or your prototyping tool. Plain and dull, right? But you know what? It doesn't need to be that way. Let's bring it to life. One click and ta-da! Not only you see the solution right there, you also get animated current. So what happens if I make the resistance twice larger? The current becomes smaller. It is actually twice smaller. Let's try that again. Now let me play with the voltage source. Watch this number turn into a mini waveform as I adjust the voltage. When I increase the voltage, the current also increases. Oh, right, it's Ohm's law. Now those textbook equations start making sense. And what's cool is that I did not have to stop simulation while making changes. It's completely interactive. Let's make it more interesting and throw in a capacitor. I'll connect it in series with the resistor. Oops, undo, delete just this part of the wire. And let's also make it a pulse input. There we go. It's pretty cool that mini waveforms show right on top of the schematic. Let's take a closer look at them in the oscilloscope. That's input, and that's output. Nicely color-coded. Let's modify the input to have steep transitions. So 0 rise time and 0 fall time. Alright, there is some charge on the capacitor. But there's not enough time to charge and discharge it completely. So let's give it more time. I'll increase the input period from 1 millisecond to say 10 milliseconds. That looks better. More current over time, so more charge. Let's see what else I can throw in. There are plenty of components to choose from. Okay, let me try this switch. I'll connect it such that I can control the input myself. One end goes to the voltage source, and the other one goes to the ground. Let's also go back to a DC source. When I flip the switch, the capacitor will charge from the voltage source. There you go. And if I flip it again, the cap will discharge to the ground. This animation makes it really easy to see how current takes different paths in the circuit. Okay, I've got to stop playing with it. Let's save it. Give it a name. RC step response. Description. Save. Here it is in my workspace. I could have saved it as public so that the community can run it and give me some feedback. That should be enough to get you started. But stick around and I'll show you more. Every circuit has a bunch of examples, starting from basic concepts like this voltage divider, to LED circuits, logic gates, op-amps, all the way to transistor circuits. Each example has some theory on the right. Let's look at some of them. Here's an LC oscillator. Capacitor is charged. Boom! Oscillation starts. Let's make it go faster. Cool. Oh, and you know how much fun LED circuits are, but you've got to protect LEDs with current limiting resistors like this one. A larger resistor will make your LED go dim. But be careful, with a smaller resistor the current will burn your LED. 50 ohms is just right, since this LED is rated at 20 milliamps. So before building a circuit, make sure you simulate it. It could save you time, money, and going to Radio Shack to replace burnt components. Another LED circuit. Here is a transmission line. See how the signal gets delayed as it passes through. This one is called interactive truth table. You can experiment with all the logic gates. Finally, there is a transistor level op-amp. One thing that is extremely useful for electrical engineering students is that every circuit shows MOSFET region of operation. See, this one gets squished into linear region. Perhaps I'll increase its width. And clone this change over to keep symmetry. Alright, all transistors are happy. If you can't find something in examples, there are tons of circuits published by EveryCircuit community. You can search for something specific like, say, guitar distortion. There you go. This one. Nice. I'll leave a comment for the author. Thanks, I'll try to build it over the weekend. Send. I'll also bookmark it. Here are my other favorite community circuits that I've bookmarked earlier. Oh, and you can see how popular each circuit is by looking at these statistics here. Number of bookmarks, comments, views, and time earned. Alright, that's EveryCircuit. You can get it as a mobile app, or you can click the link below and check it out right now in your browser. Thank you. Enjoy!